Now let us come to the next problem. We have to state the number of significant figures in 5461 angstrom. So 5461 all are non-zero digits, so they all are significant. So the number of significant figures is 4. So the rule that applies here is all non-zero digits are significant. Now the next problem states that what is the number of significant figures in 5200 meters? Okay. Now let me clarify one thing. If we are writing 5200 meters, that means this value has come from an accurate instrument. Okay. If these two trailing zeros, they are significant in this specification, but if they were not significant, the same reading would have been written as 5.2 into 10 to the power 3 meters. So in this particular case, wherein you are writing 5200 meters, that means it has got 4 significant figures. But if only 5 and 2 are significant, then this should not be the way it should have been written. It is to be written in this fashion, 5.2 into 10 to the power 3 meters. Okay, so this is a very good problem. Now the next problem, we have to find out significant figure in 35.000 mm. Okay, now we have 3 zeros which are trailing, but they are trailing after the decimal place, which is here. Okay, so if you are mentioning these 3 zeros specifically, then it means that all the 5 digits are significant. So the number of significant digits is 5. So the rule is all zeros appearing on the right side of the decimal point, they are significant figures. Now the next problem is to find out the significant figures in 0.007. Now you see here that the zeros which are leading the 7, they are insignificant, although they are coming after the decimal place also, but they are not significant. We have a rule for this. So the number of significant figure in this number is only 1. The rule here is leading zeros or the zeros placed to the left of the number are never significant. Now the next problem is to find out the significant figure in 2.64 into 10 to the power 24 kgs. Now this is a scientific notation wherein this is a numeric and this portion is exponential. So this is not to be taken care of, only this numeric portion is to be taken care of. So 2.64 has got 3 significant digits. So the answer is 3. Okay. Now let us look at the next problem. Significant figures in 0.2470 gram per centimeter cube. Okay, so you have one leading zero which is insignificant, and you have one trailing zero which becomes significant because it is coming after a decimal place. So 1, 2, 3 and 4. 4 significant figures in this number. One more problem of the same type. We have to find significant figure in 6.320 joules. So this trailing zero is coming after the decimal place, so we have 4 significant figures in this. Okay. Again similar but same simple problem. 6.032. This 0 is coming in between the non-zero digits, so this 0 becomes significant. So we have 4 significant digits here. Okay. One more problem on significant figure. Now the number is 0.0 0006032. Okay, now the zeros which are leading this now first non-zero digit 6, they all are insignificant. So we have to start counting from here, 1, 2, 3 and 4. So 4 significant figures. Okay. Now one more important problem in which two rules are being applied. 1.3600 is the numeric part and the exponent part is 10 to the power minus 5. Okay, so this you ignore for counting the significant figures. Now the number is 1.3600. These two zeros, they are coming after the decimal place. So the number of significant figures are 5. Now next problem is on rounding off. We have to round off 32.97 up to 3 significant figures only. That means you have to cut off here. Now if you cut off here, that means the preceding digit 9 has to be incremented by 1. Okay, so if you do that, it becomes 10. So 1 has to be carried forward. So this will become 33.0. Okay. One more problem on rounding off. We have to round off up to 3 significant figures. 6.098. So you have to cut off this 8. This 8 is more than 5. So the preceding digit 9 has to be increased by 1. So if you increase 9 by 1, it will become 10. So 1 has to be carried forward here. So this will become 6.10. Okay. Round off to 3 significant figures. Okay, the number is 0.0004125. So if 3 significant figures are to be taken care of, the cutoff digit will be here. No need to worry about these leading zeros. Okay, so it will be 0.00041. Now the number to be cut off is 5 and the preceding digit is even, so you will retain it as it is. So the answer is 0.000412 kg. Now let us look at the last problem for today's session, in which we have to convert 2.0137 hours into certain minutes. Okay, and we have to take care of significant figure. Now we know that 1 hour has 60 minutes. Okay, so if we multiply 2.0137 with 60, now the 60 is a conversion factor. Multiplying a number which is measured, that is in this particular case 2.0137 hours is the measured value or the given value, and 60 here is a exact number. So if you multiply a measured value with a constant, the number of significant digits in the result does not change. So if you have 5 significant figures here, the result should also have 5 significant figures. Okay, so if you do the multiplication, what you are going to get is 120.822. Okay, now this is to be rounded off to 5 significant digits. So the number will now become 120.82. So you have these many minutes if you convert hours into minutes. Okay.